Hello everyone, I hope you're doing well today. Today I present a little bit what we have, what I've in fact lectured, what we have on SlideShare regarding the courses of biostatistics. So this first course I've lectured it in 2009 and in 2012. During those years I was lecturing for the master students in healthcare, and we had in fact given them also exercises, a big list of exercises and problems to resolve, and also they had a mini project to achieve in the field of biostatistics applied to healthcare. So this will be the first chapter. It will be an introduction in fact to the machine learning section and the AI section, which will follow later. And also we'll have a coding section, and the last one will be a business section. So right now I begin in fact presenting slide by slide. Knowing that you can download in fact this course on SlideShare. You have the full reference up there, top in fact of the screen, top side of the screen. Otherwise you can take contact with us and we can send you the PowerPoint and PDF file of this course. During our training, in fact, we are not into statistics today. We are more into development, software, web, applications development. But if somebody would like, in fact, to join the platform and he has a background in statistics, we have some projects in AI. So machine learning more than really deep learning. But in all cases, they need in fact to have a background in statistics, and biostatistics will be a plus. An application in healthcare will be a plus. So to begin, the program, in fact, like I've said, is composed of 4 sections. The first section will be applied statistics to healthcare, and this chapter, in fact, is the introductory chapter. We've already saved the presentation or the scripts for everything, so don't worry. And the first section is composed of 11 chapters. Second section, you'll have 5 chapters. It'll be the artificial intelligence, machine learning, and deep learning, and complex also mathematical modeling and algorithms, and so on. Third section is the coding languages, and here also you have 5 chapters, and the last one is 4 chapters. So you'll have overall 25 chapters, in this program. So you could see this one is a free one. The other chapters won't be really, they'll be free, but you'll need to join a platform and to register, in fact, to have access to this course and so on. And some others are paid ones, and some others you need some coaching, and some others you will have a platform to practice, more or less the workshops, and some others you can do like we are doing today, projects. You can achieve some projects. So here we have statistics history. You could see, well, the beginning was in Asia, but this is a presentation of, let's say, the continuity of mathematics and algebra from India and from the Middle East in Europe, and where in fact they began quantifying a little bit the population. It has begun with Captain John Grant, in fact, who has begun quantifying the population to study a little bit the cohorts, inside the British population. But like I've said, we had many other applications, mainly in Asia, in fact, before Europe. So in Asia it has begun, I think, 2000 years before Jesus Christ. This was the beginning of the creation of numbers and also of calculation, to subtract, addition, subtraction, division, multiplication. They began a long time ago, since the pharaohs also they were into that, and geometry and so on. But here we are talking about, let's say, Western countries in Europe mainly. Then we had many other mathematicians. They put, in fact, some theorems regarding statistics. For example, what is the null hypothesis and what is the the positive hypothesis. So H0 and H1. So how you accept and you decline, in fact, a decision and so on. So they've made all what today they use in biostatistics regarding the inferences. So how you accept or decline, in fact, the effect of a, for example, drug on a disease. And you would use somehow the projection, in fact, how they've aligned the curves and how they compare to a theoretical curve, this experimental curve, and they make some inferences, conclusions with me. So all of them, they work on that, on the probability too, probability, which is very well known since some long time ago. It's a proportion, in fact, 1/2, 1/3, and decision tree. All this is based on probabilities. So you have Gregor Mendel. He was more or less into genetics. He made the contingency tables to see the efficiency, let's say, in botanics mainly, of reproduction, and who has studied also the genes, the alleles, transmission of a gene from a generation to another one. He studied more or less the heredity, what we call heredity. So he was a monk, I think, a big master in that. And Fisher and others, they are all statisticians. They worked more in developing, for example, the theorem of Poisson. It was Poisson, for example, the theorem of Carl Pearson. It was correlation of Pearson. We talk about the correlation. So it was Pearson who studied the correlation. There are, in fact, methods and techniques very easy to apply, and we'll see progressively how they implemented them. The advanced, let's say, statistics have begun with the computer science. So it's not this era. We won't present it here because we're presenting that with the AI module, not in this basic first module of basic statistics and linear models, general linear models, and nonlinear models. So it's something very well used by the biologists and physicians, epidemiologists, and so on. So it will be the basic, let's say, chapter. After that, we'll move to what we are working on recently. What we've begun working on recently, which is more or less the new methods of deep learning and big data, and the new era, of AI and big data. So it's the syllabus of this chapter. We begin with different steps of a statistical analysis. We continue with terminologies in biostatistics. Then we move to sampling methods. What are sampling methods? Knowing that we have a chapter RCO1, we'll talk about the study design, and we'll see the sampling methods also in this chapter in details. Type of variables. What are different type of variables in statistics, not in computer science? It's not the same thing. And you see it's more mathematics here. So a variable will represent, in fact, a factor, or it will represent a population. It depends how we'll transpose our table, in fact. What we'll consider as a variable. Frequency of distribution, Also here it's probability and how a distribution in fact may be assessed. How you assess in fact the distribution of a population, for example. Descriptive statistics, the main in fact formulas will calculate to quantify in fact also the values or the observations. It can be a value or it can be individual. This mean 1, 2, 3, 4, or it can be 2.5, 2.3, 2.6, 10, or 10.6. It will be a value. So, and then we calculate in fact some descriptive statistics to assess, for example, the mean of age in a population and so on. And then we'll move to the probability, normal and standard normal distributions. Here we'll see, like we've said before, how we'll transform in fact our data into a statistical distribution. So how we'll draw those curves in fact, and then how we'll make statistics, how we compare in fact to samples. For example, one sample of healthy persons with one sample of sick persons. You see, so univariate, whenever we have one variable, we compare to a theoretical in fact variable. Bivariate, we are able to compare two experimental variables. And multivariate, we have many experimental variables, and we can use sometimes some theoretical variables that we'll create by ourselves in fact. What are the different steps in statistical studies? So in fact, whenever you have a study, for example, you'd like to assess the efficiency of a drug on two different samples. A sample, it's a group in fact of subjects. Those subjects can be either sick or not. If they have a disease, we call them patients. If we don't have a disease, we call them subjects. So the subject is an observation in statistics. So an observation is something that you can assess. So we have simple observation without a specific intervention. So data collected following the study stamp. So here a sampling plan. So a simple observation is generally used in epidemiology and the big cohorts. For example, we would like to assess the effect of a dirty politician, for example, on the citizens. So, and see the reaction of the citizens on his bad policies. For example, it's simple observation. So we'll make a sampling plan, and then we'll collect the data, in fact, to analyze it. Experimentation in here, for example, will bring, in fact, a bad politician, will renew, in fact, his mandate, will re-elect him a second time, and knowing that first time he got many issues with his citizens. So, and here we are into experimentation. So we know very well that apparently it won't change because he has some kind of issues. I don't know, psychopath, or I don't know, he has an issue, or he has some orders, I don't know. And here we know very well that it will clash between the people and him, for example, and because before the reaction was very violent against his oppression, his criminality, and so on. So here we are experimenting, in fact, to induce controlled phenomena. So here we've induced, in fact, the reaction of the people, because we know very well the people are not ready to accept this guy, so we bring him back. So we are making an experimentation. But the first time, the first mandate, it was a simple observation, So administration of a drug for a specific group of subjects, like I've told you. So statistical analysis. What are statistical analysis? Deductive analysis or descriptive. So here, in fact, we try to analyze the data like it is. We call it raw data. draw data without really making any assumptions. So we'll see. We'll let, in fact, the data talk. Deductive analysis or descriptive. Its target is to resume and present the observed data in tables and graphs. So we'll use the tables, in fact, of numbers. We use the graphs too, and sometimes we use the listing. So we list, in fact, not in tables but in written, in fact, the results. So that's why whenever you are working with a big company, they have the tables, graphs, and listing. Inductive analysis or inferential, and here we make some assumptions. So we say, for example, I think that, for example, it will end very badly between this politician and the people. For example, I make an assumption that more he will increase, in fact, the repression, the bullying, daily bullying, the persecution on the people. More the people will increase the violence and reaction and protest. Maybe they can reach a revolution against him. So here we are making an inductive analysis or inferential one. So at the end, I don't know, maybe in fact the hypothesis will be increase of dictatorship or like we say oppression and persecution will lead an increase of protest, reaction, economical issues, social issues, and so on. So and here we'll make the study and we'll put this hypothesis, and we try to validate it. So we call it inductive analysis or inferential, allows to extend or generalize under some conditions the obtained conclusions, without having, let's say, a final answer. Because here we cut, in fact, the term. We say we'll study, for example, from 2023 till 2028, for example, if there will be a revolution in the country by increasing, in fact, the oppression and the persecution in the country, for example. And we'll make the study during this time. We don't know if after that there'll be a insurrection or it'll be World War III, or we don't know if in 2026, for example, after 2023 till 2025, we don't know if between 2025 and 2028 there'll be other, let's say, riots or other issues, in reason of this bad policies, managed by or administrated by this politician. So in healthcare, it's the same thing, That's why in econometry, in fact, and in biometry, we have the same laws, like we say, theorems, tools, and laws we use. In trading, we use more AI, machine learning, for the forecast, in fact. Modeling, also some modeling from statistics, but mainly we use AI. So we say if the last year stock exchange has risen, and we add other factors, and the economy is growing, and the investors are entering, and buying, so it will remain increasing. So and like that we can make some forecasts for the future, for coming 3 years, around 3 years. They can do 1 to 3 years. So this is more or less AI. So all who are obsessed in AI, who are fantasizing on AI, is something very, very easy. Very easy to apply. It's not really the big issue today in our field in healthcare. Let's say it's not AI. And AI, we implemented. Many persons, mainly like me, who are more or less conservative and fundamentals, we are more fundamentals. AI needs a lot of progress, to be able to resolve the big issue in healthcare, But I won't talk about them. They remain classified, today and tomorrow until I make my first return back to an international conference, with AIIHC International Ltd. That's when we'll talk about all that. We present them. We present some solutions we are offering, and how we'll try to fix all those issues. Terminology. So, in every field you need to learn some terminologies. It's the syntax, in fact. The computer scientists and engineers, they know it by syntax. So, in statistics, you have a syntax also to respect, which we call terminology. For example, if I tell you variable, for a computer scientist, variable is it's either a number, either a letter, either this is a variable in computer science, and engineering, or either a float, either so they call it character whenever it's whenever it's a text, for example, they call it character. Whenever it's number, it's integer, or double. You have a double and integer, both of them. Whenever it's a decimal, 2.5, it's a float, and you have others listing and so on. Those are the main, in fact, variables in computer science, in computer science and engineering. Now, in statistics, the variable it's just a measurable entity x. It can be counting, or it can be a value. Counting, which means 1, 2, 3. There's two patients, two subjects. And number, it can be either integer or a double, or a float, a decimal one. So it depends. It can be a fraction to a proportion, or a statistic to percentage. Statistic means proportion, percentage. Population values corresponding to a variable. So the population usually is, for example, if we are studying human beings, it's overall humanity, around 7 billion persons. This is a population. Now, individual or case, it's every single human being who is unique, and cannot be replaced by anyone, and he will make the history, everyone. And if he has some predators, jealous, racist, fanatics, like me, he will neutralize them, in fact, to be able to move forward without them. That's when we turn this page and we close this door, and we won't worry and never regret anything coming from this door. One or many observations performed on an entity. So, like we've explained before, it's every single person, in fact. And here the difference is the entity, in fact. So individual, it depends on the entity. So for example, the controlled blacklisted terrorist in France, for example, can be an entity. So the individuals or case are every single person, from this group, and not really all the observations of the population. Now, the observation is particular measure of a variable xi for one case. Okay, so here you can have, in fact, many observations in one group for the individual or case, but the observation is every single, in fact, measurable variable. So every single person in this group. So. And here you'll have the terrorists, in fact, blacklisted, and you have the real terrorists who are the politicians, for example, and cops blacklisting those innocent persons, for ethnical reasons, for political reasons, for religious reasons, whatever was the reason, in fact. An observation will be every single person in this case, for one case. Statistic or statistical descriptor, number which describes or resumes a set of observations. So here we calculate, in fact, some numbers which will reflect the overall, let's say, behavior of our population. But as we cannot estimate always the overall behavior, or sometimes it's very expensive, to make an epidemiological study. You need to pay to every single center the fees, in fact, of including or recruiting, including subjects and so on. So to limit, in fact, the expenses of such big studies, we sample, the data, which means we take one sample, and here there's a rules really to follow to be able to choose a group, a small group, in fact, from this population to represent this population. So instead of studying 7 billion persons, we'll try to choose, in fact, 1,000 persons from all the countries. So there's rules. We cannot choose them from Europe, for example. It won't be a sample from the planet Earth. It will be just a representation of the region, which is Europe. So whenever you want to sample a population all over the world, you take from every single country a person to represent, in fact, all the population. So subset of the statistical population composed from many observations. The size of the sample is generally called N. And the processes which lead to the creation of a sample is called sampling. Like I've told you, we are sampling, in fact, sampling was to sample, and the sample, so the noun and the verb are same thing. So we can sample the population, but we need to pay attention. Also, we need to see what kind of statistics we would like to use, in fact, comparative statistics between two groups or one group, and the size of sample. We need 100 or 1,000 observation from this population, or we need more, or we need less, to avoid the statistical bias, we call it, or the lack of power in the statistical analysis, which will lead to the statistical bias. And not, an Intel cop who doesn't like your head will call your colleagues on a platform and ask them to bias their experiments, really, to continue persecuting you for years and years. You can see, because he's an animal racist pig, so it's not really good to say this here, but anyway, so good luck to the workers, not just Yellow Vest, but all the French workers today are striking daily in reason of this, not just discrimination, but violence, and terrorism of state we are living today. And reason of some haters from this or this administration or this politician or cop and so on, who are targeting us blindly, with a lot of hatred, just to destroy us in reason of our identities, So I think all the world could understand that, and more they will extend, more they will be sanctioned. You see, in the frame of this, what we've talked before about, this experimentation. So if they are experimenting by torturing someone, and blacklisting him more and more without doing anything, and incriminating him because they are Jewish, for example, or Zionists, or Freemasons, and he's Christian, Lebanese, or so on. So in this case, the experimentation, I think, will give a positive, a validation of the hypothesis that the tensions and the riots and maybe the revolutions and insurrection will increase, So like we say in statistics, and we see it's correlated, we see it's connected, in fact. Whenever the one will increase, the second one will increase at the same time. Sampling, so how we sample, like we said before, how we choose, in fact, a sample from the population, and what are the rules to follow, Every single, let's say, method or technique has some rules to follow to avoid, like I said before, the bias. Even though today they are biasing everything, I've been with biologists, I've been with physicians, I've been with physicists, I've been with computer scientists, I've been with all of them, and none of them was respecting those laws, It's just something that you teach and learn, at university. So it's not something. Anyway, that's why we are here to try to manage some projects where really you are obliged. Otherwise, the project will lose, in fact, millions and millions of euros. Like AIIHC program, and AIIHC project, what we are developing today. I'm following them to the beginning. Even though I'm just here sometimes to coach, but at the end, I have a big responsibility regarding the quality, of the codes, results, and so on. Like every single project manager, and even though I'm the director of the company, but anyway. It's a very small company, and I think today we are a very complete also company. So we have everything, in fact. And we don't need neither Americans, neither French, neither anyone, you know. We are good as a IHC team. Today, IHC team is a Lebanese team, or, you know. So, anyway, basic statistics consider the samples as aleatory, random, and independent. Which means, in fact, we consider at the beginning that the samples don't have any relation between each other. So, for example, we won't use the same subjects in the sample A and the sample B. You know, sample A and B, they have different subjects. Subject A, B, C, D, E till Z, and then we go A0, A1, A2, and so on. So here we'll avoid the bias of observation. So it's necessary to avoid unrandomized samples. So, and also we randomize, we mix them. In fact, whenever we have samples, we mix them to have a big independent sample to avoid, in fact, the personal choice. So, for example, like I'm saying, for example, if I have an issue with a politician or a cop, you know, to avoid really having a personal effect on the assumption that the rights will increase or with the increase of violence, you know, of those politicians and cops, you see. So we'll take, for example, 5 samples of cops, you know, in different regions, and 5 samples of citizens in different regions, you know, and we mix them. We mix them to represent, in fact, the police administration, for example. We randomize them. We mix them, and like that, we won't know, in fact, the result. But today we know, because you can see at the end the result will be a trivial one, which means an obvious one. So because it's obvious, you know, whenever you are living in some kind of oppression, dictatorship, violence, you know, the tensions will increase. So the probability to be sampled or to belong to a group should be equal for all studied cases. So that's why I've said we take 5 samples, and 5 samples to have the same probability, in fact, of sampling. So if we take 10 samples of cops, you know, and 5 samples of citizens, here the comparison will be biased. And if we take 10 samples of citizens and 5 samples of cops, even though it will reflect more or less the reality, because the citizens, you know, they are, for example, 60 millions, and the cops are maximum 200,000, you know. So anyway, we'll have a bias regarding the effect, in fact, the impact and the effect of the violence, you know, of the cops on the citizens. I'm talking about this because whenever you hit someone, you touch to his health, in fact, and this is in frame of healthcare courses, you know. But here, instead of talking about predators in ecology, they used to talk about predators, you know, wolves or snakes. So here we are talking about human beings. In healthcare, we talk about human beings. From X and S bar, X is the mean, S bar is the standard deviation. We want to estimate M and so. From, in fact, like we've said before, X and S are statistics. You can call them right now statistics because we haven't seen yet what is X, what is S. We call them statistics. So X is the mean and S is standard deviation of the population. So we calculate, in fact, we can calculate the statistics of a sample, but we are interested in studying the population. The population will be, for example, police administration and the civilians. This is our population. But the sample we'll be taking will be, for example, 1,000 cop and 1,000 civilian, and we'll make the calculations on those samples, and from those samples we'll try to extrapolate, and we'll see how, to the overall population, in fact, the statistics. So we recalculate, in fact, the mean of the population based on the sample one. Okay, so this is sampling. Sampling 2. A statistical sample is composed from a limited number of cases sampled from the studied population. Okay, so I've given an example. Instead of taking 200,000, in fact, cup, we'll take 1,000 cup. The sampling gives the presentation of a population. So, also, like I've said, the sample is here to represent a population. For example, 1,000 cups will represent the 200,000 cups. You know, the sample of 1,000 cups will represent the population of 200,000 cups. So this is a population and this is a sample. And inside the sample of a random variable x is obtained by repeating n times the sampling giving x. So here it's like I've said, in fact, to have a random, we'll take randomly, in fact, we won't go and seek, for example, this cop who is more or less communist in politics, or this other cop who is more or less Freemason, or this cop who is more or less Zionist or Israelite, in fact, and this cop who is more or less Muslim, or this cop who is more or less Christian. No, we random them, in fact, we'll take aleatory a small number of cups, you know, from this region and this region and this region and this region, from Paris, from New York, from Sydney, from Washington. You could see we take them randomly like that, and we mix them. And this is to avoid the factors effect. You know, here the factor will be faith, you know, or a political factor, you know. So to avoid that, we'll mix them, in fact, and we'll compose, in fact, our big sample, big X. And we give to every single observation, or to every single cup, we'll give him an index, x1, x2, x, xn in Washington, x 100 in Sydney, and so on. A special sampling. So a special sampling, in fact, from this big population will extract a small sample, and here whenever you have a sample from a big sample, you take lowercase x. So you could see it was capital or uppercase x1, x2, and here we've made a special sampling from this big population. We've taken, in fact, from those 1,000, in fact, cups, we've taken 100 cups. So we've made a sample of 1,000 cups from Paris, Sydney, and Washington, and or New York, I don't know, or both. And from those samples, you know, we've extracted a sample of 100, for example, special sampling. And here we've mixed also the French, American, and Australian cups. So we've eliminated the effect also of country. You know, we haven't eliminated just the effect of identity, political identity, of religious identity, and so on, ideological identity. We've eliminated also the factor of country. That's why we sample, in fact, to just keep a cup, you know, a cup with his costume. So for us, and to see the effect, in fact, of the violence of a cup, you know, whatever was the identity of this cup, a cup on the civilians. So, estimator. It is a characteristic computed from the observations which allows to estimate the values of unknown parameters of a statistical distribution. So this is the estimator, in fact. We'll see how many cups, for example, will hit the civilians and how many civilians will be injured and will have traumas and won't be continue their lives. And they'll destroy their lives in a way or another. You know, won't be able to get married, won't be able to work and earn their lives. They become homeless and so on. So this will be our study, in fact. And the parameters, which allow to estimate the values of unknown parameters of a statistical distribution. So here we don't know, in fact, the parameters of the statistical distribution. Statistical distribution means, in fact, how many. This is how many cops will commit crimes against the citizens. This is so we cannot know. The values are unknown. So we try to estimate them based on the study. In fact, our objective is to study if the violence of the cops on the citizens is significant or not. It will destroy their life, it will destroy their legacy, it will break them financially, morally, you see. So we'll make a study regarding that in France, the USA, and in Australia. Okay, so this is our study, and we'll see if they'll be traumatized, because in healthcare they may have issues and so on and so on. Those victims of this police violence. Unbiased estimator. So gives the mean of statistical value. So usually the unbiased estimator is the mean, in fact, which means we have, for example, from 1,000 cop, we've taken, let's say, a sample of 100. From those 100, in fact, we have 50%, who have committed violences against the citizens. So our unbiased estimator is 0.5. So it's here it's a percentage. Sometimes we can count the number of violences they've committed. For example, racism, humiliation, disrespect, bullying. It depends on every single. We can have all those parameters. And to analyze the precise effect of every single offense against those citizens. So maybe I'll do this trial. I don't know. I'm thinking about it. What do you think, guys? Well, you cannot see me right now because I'm talking here. I'm lecturing. So defamation, for example. I won't talk about all the charges we have against them today. But anyway, we can take every single one and study the effect of this, offense on the citizens, civilians, peaceful, innocent citizens who are unarmed, they don't have any arms, neither weapons, unarmed, and who are just struggling to live in countries of persecution. Convergent estimator is closer to statistical value when n increases. So convergent estimator will, in fact, just tell you that an unbiased estimator can become a convergent estimator when n increases, which means, in fact, if you have 1,000 observations, it's much better than to have 100. And more, in fact, if you have 50,000 cops, for example, we are studying their behavior and violence and so on. Here, in fact, you have a convergent estimator because your size, in fact, the size of your sample is getting closer to the size of the population. So you are converging toward an unbiased, in fact, estimator. So the unbiased estimator is calculated usually on the overall population. Convergent one is calculating based on a sample which is very close to the population, And you have the biased one. We won't talk about the biased one. Is the one you calculate on a very small. We call it effective or number of observations. Effective of number of cops, Which means 10 cops. You cannot from 10 cops estimate, the percentage of cops, overall cops, who will commit, offenses on the citizens. So here we talk about the biased, in fact, estimator. So the mean can be, in fact, a non-biased estimator. We have also the standard deviation of the variance also. Those are the two, in fact, main statistics we use to estimate, a phenomenon. Here's the phenomenon is the violence of the police administration on the civilians. Types of variables. We have, like we've said, many types of variables, statistical variables. I've described them quickly. So we have qualitative variables. It's nominal, non-ordinal. It's the color, the form, type of treatment. For example, red, blue, yellow, violet, and so on. Form, it's a shape, for example. I mean, shape, I don't know, big, small, medium. And type of treatment, well, trauma treatment, diabetes treatment, what else? All, in fact, the health issues those citizens got from this police violence, So, anyway, ordinal, it's a vegetation coverage, scale of the wind, presence, absence. So here, you could see you have, in fact, ordinal, you have levels, predefined levels, presence or absence, there are two. But type of treatment, you can have 100 type of treatments, for example. So it's not really ordinal, it's not category, Whenever you have an ordinal, it's a category. You have a scale of the wind, like we've said, small, medium, high, and so on. Now the quantitative variables are more or less numerical variables. You have continuous, in fact, temperature, for example, you have the degrees, and height, weight, and so on. Discrete, here it's the same thing like the ordinal, but you have categories, but you have numerical categories. Instead of having presence, absence, you have 0, 1. Occurrence, number of any event, for example, the event will be, like I've told you, bullying. So you'll have, for example, from those 100 cops, you have 90 cops who have bullied the citizens, for example. So this is the occurrence, and it's discrete. We call it discrete number. Here we transform it into counting. We can transform it into a percentage. So you have 90% of the cops who commit, in fact, the bullying offense on the citizen, for example. Frequency distribution, statistical series, and here we begin studying the sample distribution. So inside the sample, we said we have 1,000 observation times 2, because you have 1,000 citizens, who've been touched by the violence of the cops, and 1,000 cops. Now we can choose, in fact, the cops who have committed some violences, but we cannot, because sometimes they hide their faces, they are special forces and so on. So we need to study overall impact of the police administration on the citizens. You can see, so that's why we go from independent samples, Simple enumeration or counting of the observations. Here, like I've told you, statistical series are based on counting percentages. We have 90 cops over 100 who have committed bullying, on citizens. A simple enumeration or counting of the observation can be ordered. Qualitative variable, like we said before, quantitative variable, you order, in fact, here. You have quantitative variable, you order them. Occurrence, number of an event, you go 2 times they've made bullying, for example, 3 times they've beaten citizens, 5 times they've insulted the citizens, 10 times, you could see you count all the violence, against the citizens, civilians, because they are citizens too, I think so. I'm not aware if they are citizens or not. Maybe they are mercenaries, some of them. They brought them from foreign countries. The total number of observations, capital N, is called size of the sample. So size of the sample, you could see usually we use capital N for the population and small n for the sample. But here, as we cannot really calculate the statistics for a population, we use big N sometimes not. It depends on the study you are leading. But whenever you are saying size of the sample, it will be n, either capital N or small n. N is the number of observations after all. Ungroup distributions, when we have multiple observations, the same value can be observed many times. So we use x index I to show different values. So x1, like we said, first cup, x2, second cup, x3, third cup, and it can be also regarding the counting. So here, for example, when we have multiple observations, the same value can be observed many times. So same value, the value may be a qualitative one. Bowling, for example, we can observe it many times. So here we say the ungroup distribution. So the number of occurrences is n, and you could see number of observations is capital N, number of occurrences is small n, but sometimes they are the same. So that's why we mix them. Capital N and small n will be the same one. Sometimes not. It depends on the study design. And called absolute frequency. You see, p, small p represents the number of different observed values. N index I over capital N is called the relative frequency. Here, for example, like we've said, 10 have bullied from 90, we said 90 from 100. So small n will be the bullying, 90, and capital N will be the size of your sample, 100. So here it's not the same thing. But for example, if you have administered a drug to the 100 cups, some kind of anxiety drugs to the cups, or some kind of, relaxing drugs, or anti-racism or anti-violence drugs, to the cups, to all the cups, small n and big N will be the same number. So the observations will be the size, in fact, of sample. So it depends, you could see. In case of quantitative variable, we order x small capital X index I, and the absolute or relative frequencies could be summed in order to obtain the cumulative frequencies. So here I have some figures. So whenever you'll be following the e-learning modules with us, you see you will have the graphs. In fact, we'll begin by showing some graphs since the beginning, and how you'll calculate, in fact, your relative, absolute, and relative frequencies. So it's just to divide, in fact. So you order x, I, something you've done at the high school, so in mathematics. So in the high school, in fact, they give you this in mathematics in statistics and probabilities to calculate the relative, absolute, and relative frequencies, and to draw, in fact, your curve. Now, descriptive statistics are used to describe a data set or sample. We've talked about this before. A data table is not enough to analyze the data. Other methods are used to understand more the data interpretation. Two groups of methods. You have numerical methods and graphical methods, and here we've talked about the tables and the graphs. They are complementary. The one will explain the other one, or even you can plot, we say, or put some numbers on your graphics. Distinction between univariate data set. So you have one variable to study. So for example, inside the police administration, you would like, in fact, to study if the violence is significant, just like that, without having a sample from the citizens. Here you use, in fact, you generate a variable from inside the police administration regarding the history in violence over the past years, and you compare this new variable, of violence calculated on the same sample of 1,000 cops. you compare it to this theoretical, we call it curve, in fact. Obtain the base, in fact. How we calculate it? We use some algorithm. Or sometimes we used to calculate that, numerically on a paper with a calculator and so on, a long time ago. But today we use a software that we'll use later, in fact, to code and so on. Two variables. Here we have two variables: the sample of police officers, in 3 countries, and the sample of citizens in 3 countries. And multivariate here, you may split in 3 samples the cops, and in 3 samples the citizens. Here we'll have a multivariate analysis. You can see. And here, not just that, you can keep the 2 samples. It's not the right example, but indeed it can be. In fact, you can stratify the cops, and you can stratify also in different countries. So here it will be the country, your variable. And you can take the violence. So you have the country, the variable. You have the violence, the variable, Those are 2 variables. And you take a third one, for example, the gender. If they are committing more violence on the girls or the boys, let's say. This will be also. Or the LGBT. Today we need to add the LGBT, up to 7 genders. Anyway, so this will be a multivariate, in fact, analysis. Descriptive statistics. What are the statistics we calculate to assess, in fact, the distribution of our sample? So here, those are quality control of our sample, to begin to see if there's some kind of bias, if we need to eliminate some cops, who are really poisoning a little bit the sample of the police administration, or also if some civilians have previously got many diseases, and they won't be really they will bias, in fact, the sample of victims. If they have already health issues and so on, they cannot be part of the sample. So we draw the data, calculate some. We plot the data, and calculate some statistics, some numbers to see the distribution, of our diseases and our variables and our observations, everything. We calculate the statistics for everything, for the observations, for the variables, and that's it. Some of the observation divided, so you have the mean, average. I won't enter in the details. You can read them and calculate them and so on. So y usually is your variable. So, and y bar, is the mean. So the mean you calculated by adding all the observations, and dividing them by the number of observations. Okay. So the variable, let's mean bullying. Bullying, you have 90 cops who have bullied, in fact, and n will be 100. So it will be the mean. It's not a good example. Well, anyway, it'll be, but it's very big, it's 90%. In fact, here it's percentage. That's why it's not a good example. So we'll take, for example, the age. Let's calculate the age of cops. So what is the age, the mid-age, in fact, of the sample of cops, of police officers? So we'll sum their ages, the 1,000 ages, and we divide them by 1,000. And we'll have here the mid-age is 30 years old, 35 years old, you see, around those ages. The same thing, we'll do the same thing for the sample of victims, of citizens. And here we'll find maybe it's a little bit less, 25, for example, or it depends. It depends. Anyway, property, what is the property? Here, in fact, from every single age of every single cop, you will subtract the mean. For example, if the first cop is 20 years old, you'll subtract, in fact, 35. So you have a negative answer. But whenever you sum everything, all those differences, you sum them, you'll have 0. It's because this is the definition of a mean. It should represent, in fact, a stability, in your overall sample. Now the median value in the middle. So the median is a value that will divide, in fact, the sample of cups in 2 halves. You'll have the median of age, for example, which age will divide 35. It's close to the mean, but it's not the mean. It may be 36. Sometimes it's the mean, sometimes it's not. It depends. So, for example, 36 years old, you'll have 500 cops who have less than 36 years old, and 500 cops who have above 36 years old. You can see. So this is the median, and it depends. If you have, you could see n is odd. So n is odd. It's 1001. You take the middle value. If n is even, you take the intermediate value. So you take. You need to order them from the smallest age to the highest age. Bigger age. So, and then you take the value in the middle, which will split, in fact, the sample into equal groups. A statistic is called robust or resistant if its value is little influenced by the changing of a small proportion of the data. So the median is more robust than the mean. The mean gives more information about the data. So indeed, the median is used to stratify. In fact, we use it to stratify. For example, if we would like to divide the sample in 2 groups, we use the mean of age, which age will divide, in fact, and this value can be in the future in machine learning and deep learning some kind of threshold. It can be used some kind of threshold really, as a criterion. So the mean gives more information about the data. It's more powerful when the data is ready to be analyzed without outliers. And the median is not influenced by the value, in fact, of the age. So it won't change. It depends just on the number, and the ranking you are doing of your observations. Those 2 measures are complementary in statistics. So the mean can be influenced by the outliers. For example, if you have an age of 100 years, it can influence the value of your mean. So what it means? So you need to delete, this value of 100 from your study. So we call them outliers, and we cancel. In fact, we fire those values from our samples. So those 2 values, in fact, median and mean, are very used in statistics to analyze the behavior of the sample, the age, to control, in fact, for the quality control, to control, and so on. And then you have other statistics. Okay, so here you can continue reading that. Then you have variance, standard deviation. Then we pass through the graphics. There'll be plotting. You have box plot. Also, and here you have quintile and quartile. The quintiles. What is the difference between quintile and quartile, percentile, decile, and so on. And here you have a histogram, how we draw a histogram, what is a bimodal distribution, what is a unimodal. So just to tell you, you'll have all those courses. This course will be for free on our platform on AIIHC.com. In the future, we'll see. It will be the e-learning module we are preparing, and we'll have that also course on different other platforms, where we have accounts. And then you have .plus and so on. So here we begin the distribution. Whenever you would like to make a statistical comparison, you study the distribution, in fact, and here you use the mathematics for that and functions. This is something also you studied at the high school. What is a function, how you present your function with a curve, and so on. Okay. Statistical tests. So what are the tests to use? What are one-tailed, two-tailed tests? What are the type of tests? Type 1, what are the type of errors too? What is the p-value significance? What are the univariate, bivariate, multifactorial, and multivariate tests? So multifactorial, like I've told you, whenever you stratify in fact one variable. So here you add a factor, whenever you have different variables, 1, 2, 3 variables, inside them you have many factors. For example, like we've said, the age, for example, if you put the age, and the factor will be the country of this cohort of cups, so you'll have multifactorial, multivariate in fact test, both of them. It depends. Sometimes it bivariate, two variables, like we said here, the variable will be variance between two groups, or the group of cups on the citizen. Statistical hypotheses. Statistical hypothesis. So what is a hypothesis? H0, and you could see they are conclusions related to frequency distribution. These conclusions could be true or false. So whenever you make your test, in fact, you have null hypothesis H0 and alternative hypothesis H1. And whenever you reject, in fact, H0, you will accept H1. H1 will be the difference, in fact, between two groups. So we won't make a clinical trial here right now. So test of hypothesis just to introduce those modules and to tell you they'll be clear, maybe in my voice, with my voice or a AI voice, and the type of studied variables. You could see type of problem conversion between two means or more. So here, whenever you have two groups, well, in our case, we won't use the mean, or if we'd like to compare the means between the police, like we've said, group or sample, and the victims or civilians sample, here we'd compare the age. So here it'll be comparative statistics, between those two groups. And it's quantitative. Qualitative will be a comparison between, like we said, the violence. So violence is qualitative. So you have, for example, what kind of violence, how many times they've offended, in fact, the victims, bullying, in physical violence, beating, or else, or something else. Sexually assaulting, I don't know. They can use any kind of violence, financially assaulting. So here we need, I think I'll make this trial. I think I'll make this cohort, more or less a cohort, I'll try to launch this study, with AIIHC International. We need some sponsors to study it, I like that. I would have validated my course. However, the logical steps of a test are always the same. Yeah, they're always the same. That's why whenever you learn this, you'll apply it forever. It becomes a routine, inside your work and professional activity. One-tailed and two-tailed tests. So it's also, we need to turn back. In fact, one-tailed is whenever you are comparing just the difference between two groups' ages. So we are saying the assumption is that the ages are different. Neither bigger, neither higher. So two-tailed is whenever you are saying the age of cups can be greater than the age of samples, and you are obliged to compare that the age of cups can be less than, the age of the victims, of civilians. So it's two-tailed test, here you'll make double comparison. So it's not the same thing. So it's either one or else. You need to fix it. So you'll say, I'll test that in fact the age of cops is greater than the age of civilians, So it will be the assumption. It's two-tailed in fact test. It's not one-tailed. Top 1 and 2 errors. This is in statistics. Whenever you reject, in fact, null hypothesis, this means there's no difference of ages, between two groups. This is a null hypothesis. And the alternative hypothesis, there's a difference, like I've told you, between two groups. So whenever you reject null hypothesis, which means you say there's a difference in ages, and there's no difference, between the ages. It's type 1 error. You could see. Type 2 error is the opposite. When you accept null hypothesis, when you say there's no difference, and there's a difference between them. P-value. So here you calculate the power effect of a statistical study by using type 1 and type 2 error, or alpha and beta, and we see this here, power beta, significance p-value. So when we test our hypothesis, so here's the probability to calculate the to make a type 1 error is called threshold of significance of test 1, and usually noted alpha. So it's alpha, and beta. And the power of a study is 1 minus beta. Okay, it's noted beta. Probability T0 reject H0 when it's false is called the power of the test. So this is something you use to calculate the size of the sample. Whenever you are sampling, in fact, you would like to take to know size of sample you would like to study, in fact. You use this formula, in fact, and also they are using this under SAS, under R. We'll make an application, not here, but during those sessions, in fact, you make an application, all of us. There's no direct relation between alpha and beta. Their values are likely to be closer to 0. In general, we choose alpha equals 0.05, and we try to minimize beta, in general, 0.1. The threshold of significance p-value is the probability under the null hypothesis to observe a difference due to the hazard. And so on and so on. Those are the univariate tests, like we've said, or it's chi-square for goodness of it. Whenever we have one variable, for example, if you would like to compare the age of the sample of cups to the overall ages of cups, you generate a theoretical variable with the overall ages of cups based on the recruitment inside the police administration, and you compare the sample of cups, or the age of the sample of cups, once of the cups to the overall age. So here we call it univariate test. It's not bivariate. And there's other methods, you can stratify also your sample, but you could see here you'll use always one theoretical distribution, and your theoretical distribution, or an empiric one, will be used based on the recruitment, inside the police administration, with the ages between 18 and 65, 64, I don't know, during those ages, and you calculate, you generate, in fact, you generate a random variable with 1 million. You can 1 million ages between 18 and 64, and you calculate the mean of this random variable. Theoretical, we call it theoretical distribution. So you'll have usually a normal distribution whenever you generate this distribution, because you have a high number of observations. The question, could the observed distribution be conformed to the theoretical distribution? Well, this is what you'll ask, in fact. If your distribution of your sample of 1,000 police officer is conformed with this theoretical distribution of 1 million virtual cops, could the difference between the observed values and the theoretical one be due to hazard? So this is why we use the statistics and the type 1 and type 2 errors. Chi2, for goodness of it, the same thing. So we'll put H0, H1. Like we said, H0, there's no difference of ages between our two samples, the theoretical one and the experimental one. So are due to hazard, there's no difference. Which means there's no difference. The observed distribution follows a probabilistic theory. Alternative hypothesis H1, the observed distribution doesn't follow a probabilistic elements necessary for calculation. So here it's a contingency table, and here, like I've told you, you need to have discrete variables. You need to discretize, in fact, your variable. So you'll have, for example, first level of ages, second level, third level of ages, fourth level. I won't enter in the details. Maybe for sure under the application we'll give an example. I've given an example to my students while making an application a long time ago. Univariate test, chi-square for goodness of it, also chi-square. Degree of freedom. What is the degree of freedom? It's number of classes. So here, for example, I think you have 4 classes. Minus 1 minus number of parameters estimating theoretical distribution. So parameters estimating is 1, is the age. So here it's 4 minus 2, it's 2. It's the degree of freedom. Conditions of application, all theoretical frequencies must be greater than 5. Calculation of each theoretical frequency. Condition of application, all theoretical frequencies must be greater than 5, otherwise we group the classes. Calculation of the chi-square, this is the formula to calculate the chi-square. It's the sum from 1 to p of the difference between the observation minus theoretical square times 2. Power 2 square, over t with the theoretical. P is number of classes after grouping. Like I've told you, we group the classes, it will be P, and here it's 4 classes. We group them in 4 classes, A, B, C, D. Okay, df is degree of freedom, it's equal, we've said it before, P, it's number of classes. It's 4 minus 1 on number of estimated parameters. Here we estimated the parameter of age, which one? It's 4 minus 2. It's 2. Decision if chi-square. So here you have a table of theoretical chi-squares. We compare our experimental calculated one to the theoretical one. So, and we decide if we reject or we accept the hypothesis H0. So if our calculated one is greater than the theoretical one, which is chi2 chi-square alpha, so we reject H0, which means there's a difference. There's a difference of ages between the sample of cops and the overall recruited cops in the police administration, which means in fact they need to change those cops to have maybe older cops will be less violent, than the young cops. So this is what does it mean, So we'll find them a cure, not just an anxiety cure, but also a recruitment cure, inside the administration. Because they allow to themselves to get involved, in other administrations and in our work and so on. So we have the right also to get involved in their administration, to make it better, to improve their work. Univariate test of normality. So this is something to analyze the distribution, of your sample. Skewness and kurtosis is to see if your curve is flat or it's a bell-shaped, curve, more or less. So this will show a little bit if you have enough observation or you need to increase the number of observations, because more you have a bell-shaped effect curve, more you are close to the population, and your statistic will be less biased, like we said before. So here you have formulas to calculate skewness and kurtosis. And you have a test of Kolmogorov-Smirnov, which is a univariate test also, which will be used also to achieve the same purpose of chi-square for goodness of it test. And here also you have many tests, in fact, of comparison, and you'll compare the result obtained by every single one. There's no a golden, let's say, statistical test. They all give let's say approximative results regarding, but whenever it's like we say, it's different, whenever there's a difference, they will always have a significant test. We call it significant test. So all the tests will be significant, and this will show, for example, like we've said, that the mean age of the sample of of cops, police officers, is, for example, less than the overall mean of the police administration, mean age of the police administration. You see, this means, in fact, they need to recruit older, cops to maintain the order and so on, and to have less young and violent, cops in contact with the civilians, directly or indirectly, directly or indirectly. And here we pass to the bivariate test, and here once we finish that, we've justified, in fact, and verified the age, of the sample of cops. We'll compare it to the age, of civilians. And here we go through a bivariate test. And here we need to stratify the age, for example. For the contingency chi-square, it's for independence of two variables, And here it's made for the qualitative variables. So whenever you have a quantitative variables, like the age, for example, qualitative variable will be, here we'll use that, for example, for the violences, kind of violences, bullying, for example, it's qualitative variable. Beating also is qualitative variable. Sexual offenses is qualitative variable. Discrimination is qualitative variable. Hatred is qualitative variable. Abuse of power is qualitative variable. Terrorism of state is qualitative variable. You could see all this can be analyzed by using contingency chi-square for independence. Or a chi-square for independence, same thing, Usually called chi-square, for bivariate analysis. So we'll use that, in fact, to compare. For the age, we'll use later, So here for the age, we'll use either the goodness of fit, chi-square for goodness of fit. Otherwise, we use a lot Kolmogorov-Smirnov, in fact, test. We haven't detailed it here. There's a reason, because we are offering also some coaching. So if you have any question, you can take, for example, 1 hour of coaching, and we may answer you on those questions, Otherwise, you need to follow the applications. Here we'll have applications under R, so... Or during the exercises, we'll give you the formula of Kolmogorov-Smirnov, and we'll ask you to calculate. This is what I've done with my students before. I've given just the formulas here, and we made some exercise quickly. But I was very fast, Some of them weren't able to follow everything. So I've stopped, and I've explained that during the exercises and so on. We made an application under SPSS, not under R, because they didn't know to code. So as I couldn't present, a coding session like I'm doing today with the computer engineers and computer scientists. So we've worked under SPSS. We can work under Excel today also. So we don't need really SPSS or NCSS or Statistica also, or MATLAB also. Under MATLAB, you need to code also, a little bit like under R. And here we begin comparing if, like we've said, the increase of violence is correlated with the increase of, or increase of violence is correlated with the increase of hatred, for example. We'll see how many citizens have been beaten, and we'll see if it's correlated with the number of, or with the percentage of, for example, racist cops, for example, or with the, we'll see, in fact, we'll take every single variable. So here, for example, bullying is a variable, age is a variable, Racism is a variable. You could see, or discrimination. We can put them in a category of discrimination. All of that, you can study if it's linked to each other. If the age is correlated with the violence, like we've said before. So, if also the violence is correlated with the health issues of the civilians. And here we need another variable, which is health issue, So, I think I will launch this clinical trial, or I'll talk with a academician, with a professor at the university or someone. We'll launch this trial. I think it's very important, mainly in the Western countries today. So maybe we'll do that. I don't know. Regression and correlation, you could see it's whenever you have two variables and we'd like to see if they are correlated. So if they increase together and decrease together, or if they are not correlated. If, for example, the violence will increase but the age will remain the same, the age and violence are not correlated. Y is explained by X regression. Here we go to the regression. It's whenever you have two variables and you can draw a two-dimensional, 2D in fact, plot like you were doing in the college. The college before the high school, secondary college. Secondary college, not the university, the college, post-baccalaureate college, no, secondary college. Used to draw, in fact, the increase of temperature with the increase, with the decrease of water on Earth, for example. So, first variable would be temperature, second one will be concentration of water on Earth, or quantity of water on Earth, Here with time, so you have the time, yesterday, today, tomorrow, serial, it's a serial variable, temporal variable. A statistical test could be temporal, I don't know if you say time series, because them time series in fact variables. A statistical test could be performed with both methods in order to estimate a p-value and verify if the association is significant or not between the two variables. Okay, here we will do a statistical test, complementary one with the correlation, to see, and that's why we make the regression to make a statistical test. So, and here we began the modeling, and here we draw a model. For the correlation, you have the value of Pearson correlation. You see R, XY, the covariance of XY over this square root of the variance index X times variance index Y. And the covariance you calculated by using this formula. It's the sum from 1 till n of all the observations. This is what it means, in fact, I equal 1 to n of all the observation of x1 minus x bar, which means the first variable observations minus the mean of this variable, times the second variable observations, every single observation minus the mean of the second variable, all over the number of observations and covariance. Okay guys, so like that, the correlation is between 0 and 1. 1, there's a correlation, 0, there's no correlation. A medium correlation is 0.5. So between 0.5 and 0 and 1, you need to calculate the p-value. So to know if there's a correlation or not, because you suspect that there's a correlation between the violence and health issues, if you have 0.6, but you are not sure, you would like to be certain that there's a correlation and it's statistically significant, So that's when, in fact, you calculate your p-value, and to calculate the p-value, you need to fit a linear model, between those two variables by using this model, y equal ax plus b plus epsilon. You know, ax plus b is something also you've done in mathematics during your studies. It's a high school. You know, secondary school, you've begun secondary school, but mainly in the high school, you've done that. So it's how you present a line, you know, a line between two variables. What's missing here is the graphs, you know, so we'll see this later. And here, there's a method for that. We won't enter in details of this method. It will be explained later in the descriptive statistics chapter. Okay, so whenever we don't explain something here, you need to follow this coming chapters, in fact, to see in details what is a simple linear regression, what is the least square method, regression curve parameters between two variables, and so on. Now, bivariate tests, here parametric tests, you have parametric and non-parametric tests. Parametric tests is whenever you have usually numerical, you know, numbers and so on. Non-parametric tests, and it requires a normal distribution, you know, so you have a distribution, normal distribution, you have a numerical one. It's quantitative, more or less, statistics. Whenever you discretize, in fact, in categories, you won't have a normal distribution. It will become non-parametric tests. So it's when you compare two variables. So well, I used to have 80, 85 over 100 on that, but here in France, you know, we are all losers, you know, and we are dogs, and what we are also thieves in the country. We are slaves. We are hookers too in the country. So you know, transform successful persons coming from other countries into, you could see, into loser, and they enjoy themselves with a lot of sadness, you know, by retaining us in the country to continue treating us like that. So it's been 21 years, you see, it's over. It's over, we are doing this study, you know, and we'll present it to the judge, you know, whenever we go and talk to the judges, you know, in the justice court, we represent them, those studies we've made, in fact, on the police administration and their violence against the citizen. It's in healthcare, you know, it's a study in healthcare, because they need some medical care, you know, some psychological, you know, assistance, like we call it. So based on studies, you know, based on real sciences, not based on their defamation and lies and hatred and so on. So in order to test this equal distribution, so to test the distribution, in fact, of a sample, like we've said, we've used Kolmogorov-Smirnov for a univariate test of normality, because it's used for the univariate, in fact, comparison. And if you would like to follow in details those chapters, you need to follow those tests. You need to follow the following chapters coming later. At the degree of significance, so if there's no, it should not be significant. In fact, less than alpha, we reject H0, so there's a difference. So you don't have a normal distribution. It should not be significant. So this test should be negative, in fact. So the p-value should be greater than alpha. Alpha is 0.01, 0.05, 1%, 5%, 10% maximum. We never take 10%, but it's 1%, 5% usually. We can go up to 1 per thousand if we would like to, but whenever it's less than 1%, it's significant, you know. If you go less than 1 per thousand, just to say, we confirm that even with change effect, the design of the study and samples will always have a significant effect difference between two samples. Okay, so the parametric tests are following on. Student for dependent or independent variables and one-way allowers. What we'll see here in this chapter and the following chapters of descriptive statistics. The non-parametric tests are Wilcoxon, Mann-Whitney-Yu, and Kruskal-Wallis, in fact, tests. This is whenever you have discrete data or qualitative data, categorical data, which is whenever you have a quantitative data with a non-normal distribution. You avoid using student test. So you need to test that. And those are the statistics, how you calculate the student T statistics. T-score, we call it also T-score or T-statistic of the bivariate test. Here we compare the means of two samples. Like we said before, if the mean of the victims is 25 and the mean of the group of police officers beating them, or offending them is 35, here T score will be, greater than T alpha. T alpha, you found it in a table, and this is the course of statistics. We'll do it later, in the following chapter. Descriptive statistics, we describe everything regarding the calculation. And this is what I've done with my students, in 2009 in the exercises. So during the exercises, I've told them, put it beside, don't really apply it right now. And then I've distributed to them, in fact, the tables of statistics and everything. And for the bivariate test, it's a one-way analysis of variance, or one-way, we call it also ANOVA. And here, you need to calculate an F score, in fact, by using the variance between groups divided by the number of groups, K minus 1, over variance within groups, square divided. And there's a way to calculate those variances, Also, this one, we'll see it later. Now, JLM ANOVA is a multifactorial test. Whenever you have multiple factors, the factors can be, like we've said, bullying can be a factor. Whenever you transform a variable into a factor, to see the impact of this factor on the age, for example, or on other factor, which is healthcare, health issues. So, for example, if the health issues will increase with the increase of violence. And here you can say, for example, if one by one, if we add to the bullying sex offenses, or financial offenses or discrimination, all those factors can be added, in fact, progressively. So, and we'll see if we'll always have an impact of this violence, overall violence on the health issues of the victims. So this is factor A, factor B. So factor A can be bullying, factor B can be discrimination, for example, or insulting, and so on. We'll take a concrete example. I write a whole exercise regarding that, from A to Z regarding this example. Police administration violence against civilians. I'll take an example. In many countries, I don't think they'll give it in the national exams. For the baccalaureate, it's a little bit for preparatory, in fact, schools after the post-baccalaureate, in fact. But they can. I write it, in fact. I will make the study. Concretely talking, it won't be me. It'll be someone else collecting the data, making some statistics, collecting the data. Hopefully they won't terrorize them also. Hopefully so, we'll see. Okay, multifactorial test, multiple linear regression, and so on and so on. So, multiple logistic regression, what is a logistic regression? We use it here. I presented that to say whenever we have a qualitative, for example, variable, for example, has issues or not, 0 and 1, and we would like to study all those factors on this variable, we use multiple logistic regression, for example. This is how I presented that, I still remember. And I've given, in fact, the formula here, exponential beta 0 plus beta 1 x over 1 plus exponential beta 0 plus beta 1 x, and so on. Survival curves is something else. It's a big chapter. This is a chapter if the victims will die or remain alive, so how many victims have died with the yellow vest, for example, in reason of the violence of the cops on them, and how many are continuing, with the diseases, and so on. So we can do this study also. So survival curves. I won't explain here. There will be a chapter on it also, a full chapter regarding that. But this is what we use. What is the method of Kaplan-Meier, the log rank test? I've taught all that, private courses and also for my students in full classes. Calculation of probability to survive at each time. So here, how we perform concretely, what is the statistics that we use. So here, the probability to survive, we use it, and we define V, index I, number of survival. We calculate, we count the number of deaths during the interval T1, T I minus 1. So this is something, a study, you make it backward, You go from now backward 5 years, for example, and you make this study. For example, we take as a sample the sample of yellow vests, or protesters, all the protesters, but yellow vests who have been in fact protesting for 5 years. How many of them have died during this police violence, and how many of them remained alive, you see. And we make some also comparison to study which has impacted more this deaths, for example, which kind of violence, for example. So here it will be the physical violence, for example, let's say, or the hatred. What is the impact of the policies, of this police administration? And for example, we propose if there's any policies, they are neutral, politically talking, if this mortality will decrease or not, So this is why we use survival curves, to improve a little bit the model, where we are working. Here it's a society model, we are working inside the society. Survival curves also, how we calculate, in fact, the probabilities. Here you could see theoretical probability, how we calculated of deaths at instant I, and how we did use to calculate the frequency of deaths in each group at instant I is, let's see, and we know it, and so on, and so on. Now, multifactorial tests, survival, also how we perform a chi-square, in fact, chi-square, you could see with 1 degree of freedom to compare the mortality. For example, if we'd like to compare the mortality inside the yellow vest and the mortality inside the police samples, the cop sample, we can use this. So I don't know if any cop has died or not. So we need to compare the mortality inside the two groups, while always having a confrontation, against each other, so and so on. Well, it'll be a very interesting, exercise to write and to achieve concretely, with the right exact numbers. So maybe I'll make some investigation regarding the numbers. I'll read some reviews. I'll try to collect some information from here, and I write this exercise. It'll be very important for the coming, let's say, 5 years. What is the Cox model? When we use, in fact, quantitative and qualitative variables or cofactors, you could see, as cofactors, we use the Cox model. So whenever we would like to study the effect of, the violence, bullying, we'll add them all, we can add, and the age, like we said, we would like to add the age to the violence, physical violence and bullying on the mortality, we use the Cox model. And to end, what is the multiple analysis of variance or covariance? So here we have the variance and covariance. We won't enter into detail. It's when you have, you could see age, number of persons. You have many factors and many variables. You could see and satisfaction. Here we have two factors, the number of persons and satisfaction. So this is a Mancover multiple. If you consider the age and number of persons variables, I would like to study in fact one factor, satisfaction, it's a MANOVA. So this is how I've explained that, I think. So MANOVA is multiple analysis of variance. So you have two variables in fact and one factor, and whenever you consider the age one variable and number of persons factors and satisfaction is a factor, you have MANCOVA, which is multiple analysis of covariance. Okay, principal component analysis is mathematics, is geometry, this one, and algebra. So we need to extrapolate many dimensions, whenever you consider your variables as dimensions. So you have 5 variables, you have 5 dimensions. You would like, in fact, and usually it's the observations. So observations, you would like, in fact, to project your observations on the variables. So usually the variables are the dimensions, are your space. So you have 5 variables, for example. You would like to reduce the number of variables to 2, in fact, to project, to see how your observations are grouped. So let's give an example, concrete example. If you would like to see how many persons, have been beaten, or if the number of persons beaten is greater than the number of persons who have been insulted or have been bullied or so on, you make this kind of analysis. And here you will have, for example, 3 grouped here, in yellow as bullied, this will be a bullying factor. And here you'll have, in the middle, you'll have, for example, the beaten persons and so on. So otherwise you can extrapolate, you can consider, in fact, the observations as variables, and you can make the same thing. I won't talk about this right now, we'll give a concrete example, but you can transpose your matrix and apply the PCA, principal component analysis. So you'll have the same result, but here, for example, instead of having the civilians, instead of having civilians, 3 civilians, for example, beaten, and 4 civilians, bullied, and so on, you'll have here, for example, the group of factors. So you'll have here, if you transpose, in fact, into the same PCA, you have, for example, here the group of moral abuse, for example, bullying, insulting, discrimination, and so on. So this will be your group here. Here down there, for example, you have this group representing the physical violence, beaten, injured, and so on. Here you have the long-term incapacity, for example, jobless, post-trauma stress for years and years, and so on. So you can see, you can transpose and change the meaning of your graph, and it won't be the same one. It won't be the same one. Anyway, we've ended here our first lecture and the fields of application, genomics, transcriptomics, proteomics, metabolomics, clinical studies, epidemiology. So here it was more or less epidemiological study regarding the violence, of the police administration on the civilians. So it was more or less the study we've done. It was in epidemiology. It can be used in pharmacology, pharmacogenomics, and biology, agronomy, and ecology, and many other fields. Summary of different steps of statistical analysis. Whenever you have, in fact, your data and your database and everything, you would like to make a statistical analysis by using what we've seen today, what you'll be doing, in fact, step by step, progressively, transform numerically each observation if it's not numeric. So indeed, today you cannot analyze a alpha numerical, let's say, database. So you need to have numerical values. So if you have A, B, C, you transform them into 0, 1, 2, or 1, 2, 3. So that's what it means. Retrieve the noise signal and replace the missing values. So here whenever you'll see, in fact, some discrepancies in your data. In fact, you will see this in your box plot if you have some missing values also in your database for some COPs you haven't assessed, in fact, the violence, for example. It will be missing value. So sometimes there's some algorithms that can find this value. Sometimes you can either delete or cancel this observation. Otherwise, you can keep it and put a value 0 or 1. Usually we put NA. So usually we put NA, and whenever you have NA, the algorithm is able to replace it, and to perform the statistical analysis. Noise signal, here we don't have a noise signal. Noise signal is whenever you have an experimentation. For example, if you have a big bomb falling between, for example, the cops and the civilians, this bomb will be a signal, noise signal. Because it's not really the effect, or the act of the cops on the civilians. So here we erase this signal, no signal from our study. Normalize the data and prepare the data table for analysis. Here you normalize the data between Paris, for example, Washington and Sydney. Whenever you see some discrepancies in your box plot, you can normalize them. For example, if the overall age in Washington is very low, and less than the overall age of the French cops, you can shift it, you can normalize, we call normalize it. This is to avoid discrepancies in your study, Perform the differential analysis, t-test, ANOVA. So this is differential analysis. It's between two groups, Find similar subgroups. This is the clustering k-means and PCA. So similar subgroups was the PCA also. Principal component analysis. We use it, but it's not very precise. It's global. It gives a global idea, regarding distribution. And usually, whenever you would like to group in 8 groups or 2 groups and so on, you use the k-means. Whenever you would like to have more or less a tree, a tree of observations, and to see in fact those 3, for example, aligned in a tree, the tree dendrogram we call it, use the clustering. For the clustering, you'll see also this later in the machine learning. In the machine learning, we see the clustering, supervised, unsupervised method in the machine learning. And it's very easy, we calculate the distance between 2 observations, and then you cluster them into groups, while the classification is something else. So this is the violence, for example, bullying by the demeanor of the neighbors. We can add it as a variable. So I'll be launching that, I'll be publishing that. I don't know where I'll publish it, in which journal. And this will show the high violence effect and impact of the high violence of the police administration in the Western countries, mainly in the sample of 3 countries, Australia, the USA, and France, on the citizens. Well, the study will be 5-year study, from 2018 till 2023. It will be retrospective, we call it. In statistics, we call it retrospective study, in fact. Okay, guys, so that's everything for now, for tomorrow, for day after. This is the theoretical course. Usually you'll have a more detailed course with exercises and mini projects, practical works, whenever we have coding, and everything will be ready in 2024. It'll be released from Lebanon. I've lectured that in Lebanon, so between 2009 and 2012. You can see 2013, yeah, I've ended in 2013. So, and I'll turn back on track, and whenever we are back on track, you'll have an accent, which will be more or less, I think, between the American and British. I found a mid accent between both of them. Neither American, neither blah, 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 coffee, blah, blah. So we'll find tea. of Turkey. Okay, we find something between them. I don't know. Maybe the Lebanese accent will be fun. Lebanese English accent. I don't know. I'm kidding here. So we find an accent between both of them. And hopefully you will like this module. It will be a unique module of e-learning. Module unique once per life. It will be once per life unique module for sure. We will update it whenever we'll have new techniques. Mainly in deep learning, machine learning, we'll add them to the course for sure. But it will be a unique module. And enjoy it. Enjoy it. So if you have any question, don't hesitate to contact us on our email. Not mine, I've put mine here, ref at AIIHC.com. Yeah, it's mine. You can use also the one of the company. It's contact, CONTACT at AIIHC.com, but you can also contact me personally on this email. Okay, guys, with that, I would have finished, in fact, everything. Keep safe, all of you. And what do you want me to say? Good luck to everyone. If you have exams, quizzes, and you would like to have, let's say, coaching, don't hesitate to contact us. We'll be here really to enlighten you regarding what we are developing. Now, this module is optional. It's an option inside AIIHC platform. It's not really the main, what we call business line, not product, but business line. Main business line will be more or less certifying some interns, in those fields of AI, of machine learning, of applied statistics, and so on. This will be more or less the business line. And also we'll have other activities in coaching, for example. It will be also another business line. So this first business line will be internships or apprenticeships. Apprenticeships in British, or in English, American English, it's internships. This will be the first business line. Second business line will be coaching, and this e-learning module will be in the frame of this coaching. The third business line will be products, commercializing some products in healthcare, and something I'll promote next week. Okay, guys, next week, or not next week, the week after, or not, when? The 11th of October. Not the week after, the week after, the after. Okay, in 3 weeks. So in 3 weeks, I promote that, It will be, the products will be presenting from Lebanon, or made in Lebanon, with some interns and myself too. So I'll be involved in all that. I'm working day and night. Whenever I'm not working, I'm working, You could see I've prepared an exercise, a cohort, in epidemiology, without writing anything. But whenever I'm not working, I'm working. You can understand. I think you can understand. You're smart enough to understand. Even though they haven't understand, and they don't want to understand, and they will never understand because they are so racist, and disgusting. So, but I think everybody can understand today, except them. And the magistrates too. And politicians too. I think so. Anyways, but much better to not see me today. I don't wish to see myself neither. I would better really forget this matter. And in all cases, I could earn, by lecturing this module, more than $500 per month, from one university. So you can lecture it in 2 or 3 universities and you have your wage, in Lebanon. So just to tell you that the story is over, with those countries where there's any respect for the immigrants, because of my name maybe, or I don't know, my face or my accent. While my French accent is less weird than my American accent. I don't know, I cannot tell you. In all cases, I will never accept their involvement in my privacy, with my beloved persons and girlfriends. That's why I've decided to return back definitely to Lebanon to settle there. Their violence doesn't have any limit, Their violence doesn't have any kind of limit. So this is why they deserve, a study regarding their violence on us, the citizens and civilians. It'll be for 5 years, and we'll update it, every year. We'll make it a yearly renewable study. Every year we'll release our tables, graphs, and listing, regarding this violence of police administration against the civilians. Not just the protesters, all civilians. You could see I'm not protesting here. I'm in my place. I'm living this violence today. And since 21 years, more than 5 years. So we need to make a real study regarding that and to present it to the United Nations Human Rights, Justice Court, and even Chart, to modify their chart regarding the freedom of speeches, freedom of exercising, freedom of getting married with a girl and having kids. All those freedoms, they need to rectify them, in the light of this new epidemiological study. Okay, guys, it was everything for now. They think themselves above everyone, but you could see we have nothing to do with them. They need to disconnect and fuck off. Otherwise, things will be much worse for them, worse than today for them. We may enter I think in a civil war or something like that, if the country will be divided, and they continue doing that for us, for years and years, they won't stop, maybe we'll enter in a civil war. Because whenever this violence is from one side and the second side is defending, himself, is not really doing any harm to anyone, but defending himself for 21 years, and they continue and continue, and there's no limits for them. They are assassins, you can understand. So maybe this will lead those persons, living this violence, to make an appeal for a civil war, in the country. Maybe, I don't know. We'll see. We'll see how the judges will prosecute them in our law cases and complaints. We'll see. If they'll wait 3 more years, 3 more years. During those 3 years, we were living this violence. You can understand daily. They will extend, 3 more years. To do what? To continue killing us? So whenever we decline someone, you can understand. I think you could understand, but they don't understand. He fucks off, even though he's a police officer or a politician or a governmental employee, even a judge or other. Because they have their work in the public administrations, and we have our work, in our private companies. And more, we are not working in the country, where we are living. So we are trying to work online to avoid more and more violence and interference on our works and jobs and so on. They are disgusting. This is a word, fully disgusting, and I haven't got any good memory from this country today called France. Neither from Australia, neither from the USA, Those countries are the most violent countries, and today the political systems. I won't talk about this right now, but I'll show, in fact, numerically talking in detail, that the politicians belonging to a precise, side and party and so on, and not just parties, but a side, a lobby, are behind all those violences. And we'll see the impact of those violences, and we'll see how much they will pay us, as damages and interest regarding this violence. Not just to me, but to hundreds like me. Anyway, you can see there's no scandals here. There's unprofessional criminals in the public administration. So we won't burn anymore, of anger. Hopefully this will end one day, for me and for others. And you could see, as I said, this will end by August 15, 2023, then they've extended, They are extending since the first day I've stepped in this country, and they haven't stopped since. So it's time to give them what they deserve, and to leave and to never ever return back to see what will happen to them. And hopefully they will burn alive, all of them, and nobody will shed a tear on them. Hopefully so. Anyway, this was in science, to demonstrate to everybody that what they are doing is fully illegal, and they are outlaws today. And they put in us the hatred, and disrespect toward them. While we used to consider them, colleagues like everybody. We used to consider them colleagues like other administrations, There's many administrations in the country. There's not just one or two administrations. We used to consider them colleagues from other administrations. Today there are the Ministry of Health, the Ministry of Defense, the Ministry of Economy. So all the employees of those administrations, are colleagues for us. This is not just one administration. So today they've shown to the whole world what kind of corrupted, in fact, and violent, this is the word, low-level administration they are. We said it and we repeat it clearly. 5 years of hell will make them live. If they won't stop, and they will fuck off, definitely. Don't live with the neighbors, third parties, like we call them, from our lives. Thank you for your time, guys, and hopefully one day you'll be my student, or I'll be lecturing in your college and university, or you'll be one of our clients and leads or sponsors on our platform, AIIHC.com. I'm working daily. Now, the interns who were with me, I think they can work alone, they are autonomous, they can be independent. So I've returned back to my job and to develop really this platform and to begin preparing the e-learning modules. You see progressively, and this is the first one. As an introduction, you could see we haven't went very far. Now the second one, I won't present it here, but will be the study design. How you'll make a design of your study, and you select your variables and number of observations and what kind of tests you will apply. In fact, how you decide that, and so on. So we call it study design, and what kind of design you have. So I've told you we'll go backwards. So this design we call it retrospective design, and if it's parallel, two groups will never meet, or you can mix them and so on. So for example, some civilians can become police officers and oppress the civilians, and some cops can become civilians, and be oppressed and beaten by the cops. So this is, we call it cross-sectional, cross-sectional, longitudinal and cross-sectional, but also mixed. It's a more or less mixed study. So I don't have the full names right now, but I used to have them a long time ago. And cross-sectional is when you stop the study at a certain time t, and T0, T1, T2. After 5 years, for example, if we study today a study that has begun, in fact, 5 years ago, we can stop it right now and study it right now. It's cross-sectional. If we are studying the study, if we are studying the statistics, not the study, if we are analyzing the study from 5 years ago till this day, in fact, it's longitudinal, in fact, analysis. You could see crossover. I think we call it crossover study. So whenever you mix them, it's crossover. Crossover longitudinal study. Crossover study. Yeah, I still remember that. It's crossover. Yeah. Now, whenever you mix, in fact, the two lines, the two population, two samples, you mix them and you reverse the rules, you know. In treatment, you will treat, in fact, differently the two groups. Anyway, we can use this crossover also. We can use everything on this study, you know, epidemiological study. And then we can do some clinical studies on the cops mainly. And also, you could see the civilians are treated whenever they are offended, they have diseases, they are wounded, they have trauma, they are treated. So also we can make some clinical studies and treat also the cops, you know, to decrease this violence against the citizens and so on. Well, anyway, we have a lot of ideas regarding this new, in fact, clinical trial or epidemiological trial, which can become a clinical trial in the future. I'm talking about today. Thank you for your time, and with that I will end. Have a nice time, and see you in another, in fact, podcast or webinar or lecture or workshop or pitch. Anyway, see you later. Bye bye.